All right, the last couple of problems I want to do here are ones involving radicals and simplifying radical expressions. Now, overall, I noticed that folks did great with adding and subtracting radicals, with simplifying radicals. My one concern was where we had a mix of variables and where we had radicals in the denominator. I want to point out that something is not simplified if you have a radical in the denominator. So leaving an expression like this is a no-no. Don't do this. Also, you don't want to leave something like this because I is really the square root of -1. So in this case, we would take the same approach either way, multiplying the top and bottom here by I would get 4i over 3i squared. That, of course, is equal to -1. I would get 4i then over -3, and that would be fully simplified. Over here, I would be multiplying by the square root of 3, and this would become 4 square root of 3 over 3. This is considered fully simplified. So let's look at some problems from the summer packet, and the two examples are from chapter 4, problem 8, E and F. So I have the square root of 16x y squared over 27 z to the 5th. And I notice that 16, that's 4, and y squared, I'm going to be really picky and put the absolute value of y. If you hadn't put that, that's okay. I didn't take off any points for it, but technically you do want to put that absolute value of y because we are taking the primary square root here. All right, now 27, not a perfect square. That is 9 times 3, so I have 3. Z to the 5th, also not a perfect square. So I'm going to take z squared. Now that is going to be a positive value regardless of whether z is positive or negative, so you don't need to put it in the absolute value signs. Underneath my radical is 3z. This is not done. I need to multiply numerator and denominator by this square root of 3z because that will force the perfect square in the denominator and it will allow me to simplify. So I'll do that right away. And I will get all of this going together under a single radical. These will simplify to 9z squared, or what will be the square root of 9z squared. That square root would obviously be 3, and then the absolute value of z. So I'm going to just simplify this whole thing, and I'm going to get 4 times the absolute value of y times the square root of 3xz over 3 times the absolute value of z to the 3rd power. And again, that's just because I want to force that positive value for the principal square root. Again, I wasn't super picky on this notation. The next problem here that I saw was F, and F was kind of an interesting one because we had to use fractions and radicals, so that was pretty exciting. So now what I would do here is I would probably do the addition first and kind of clean it up later. So I have to multiply numerator and denominator in my first fraction by 5, and numerator and denominator in my second fraction by 2 radical 3. Okay, so I'm going to now have 25 over 10 radical 3 plus 12 over 10 radical 3. So this is good. I can add these together. I get 27 over 10 radical 3. Again, that radical 3 in the bottom is a problem. I need to multiply numerator and denominator by radical 3. This is square root radical 3. And that's going to give me 27 radical 3 over 30 for my answer. Please note, if you left your answer looking like this, I marked it wrong because I need to see those radicals in the denominator.